Okay, so this is what we see as interesting. So although we passed using the same variable names a, b and sum that we have here, the memory addresses that it gets allocated once it enters function add is very different. And this is what is called passing by value, because we just pass the value of these functions. Now once the program goes into the function add in this function here, it allocates a separate set of memory for each of these variables holding the same value as these variables in function main. So hence it is called passing by value. Now let's see what happens once we move out of this function. So once we move out of this function, so we go F7. So in this case C would have value of 15, as we can see here, 10 plus 5, and then we return from this function. Now if we look back at these variables a, b and sum, addresses of these, it is no longer the same ones that we had before, 22F8. It has been reset to the values that we have seen before. It is 22, let's see, okay, so this address is actually 22FF44. So this one is 22FF44, and it gets decremented in order of by 4 bytes for each successive variables. So what we see here is, once we get out of this function, all this memory location gets destroyed, and we are back to the memory pointing to these locations. So this is actually what happens when we to the local variables, which are also called the automatic variables. Now this is where the name automatic comes from. Automatic variables are basically the ones whose memory gets allocated and deallocated automatically when the function when the program enters the function or exits it, respectively. So what happens in this case is, once the program entered function add, it allocated all these memories for the program for these variables, local variables or automatic variables inside function add, and once it exited the function, executed and executed the function, all this memory gets deasserted. So this memory gets becomes free again automatically, and hence if you change some value between at these locations a, b, c, so let's say if we have this variable c and we want to see what the value is, it would have been destroyed. This value would no longer be present. Similarly, let's say if I wanted to move, if I wanted to pass this value, this passing by value here as sum, and let's say if we made something as sum is equal to a plus b, if we didn't know about what happens behind the scene, we would think that if we passed sum in the form we just did in this function as a third argument, and we added sum like this, once the function returns, the value should have been updated. But that is not true, because the sum that we are talking about inside function add is a different copy, and although the sum gets updated within this function, once it exits it, this variable gets destroyed and it holds just some junk value, or actually not a junk value, since the variable name is the same, it'll actually refer to this variable name and this variable at this location, and hence the value would not have changed. Okay, and this behavior of the data structure, this particular data structure is called as stack. Now a stack, basically in behavior, it's a last in first out data structure. So whatever was last in, so in this case let's say variable c was last in and it was allocated here, and for the function, as we can see from here, the rightmost variable is the first one out, first one in, and the first variable is the last one in. So basically sum is the first variable that adds c's, and then b is the next variable, a is the next variable, and hence when we look at this, sum gets allocated first, b gets allocated next, a gets allocated next, and c gets allocated after that. So that is the last in first out data structure, or the stack. Now next we will consider how do other variable types like static or global, where do those get allocated.